Welcome to the Daily MBA, where business wisdom is served fresh and fast, straight from one of the top MBA programs in the world. I'll give you summaries of my lectures and readings, as well as the most important insights gained from an MBA, so you can apply all of this knowledge in every business. Let's get started. In today's episode, I'm going to start talking about annuities and perpetuities, because these are the formulas that you're going to need for calculating the present value of the most important financial assets that you can get, bonds and stocks. If you need a short reminder, annuities are fixed payments that you get for a fixed amount of time, while on the contrary, perpetuities are fixed payments but that you'll get in an infinite horizon. So what's usually happening around this two is that you either want to know the future value or the present value that you get from the annuity or the perpetuity. And for this, it's very simple. Let's start looking at the formulas. First, for annuities, honestly, the formula is horrible, and I never look at the formula. But what I'm going to do is instead use Excel, because Excel has a specific formula that you can use for knowing this value. When you use Excel, you can type equal and then PMT, like payment, and then over there, you'll be able to introduce all of the factors that we're usually using for computing the present value or the future value, which are time, rate, the payment, which is going to be the annuity, and the cash flow that you have, either the present value or the future value. When you compute all of this, Excel will automatically give you the payment. And so these annuities are usually the ones that banks are using for calculating the loans that you have to do, the payments and the periodic payments that you have to do for your mortgage, or different types of assets that require a set amount for a specific time. So the annuity formula, you can calculate it yourself with this Excel formula, and it's going to be very simple. The only thing you have to remember is that Excel will give you this value 1 year before the cash flow starts. So let's say I'm buying a house this year, and I'm going to start paying this exact year the annuity, and I want to calculate it. If I do it through Excel, Excel would actually throw the present value into last year because it would give it to me 1 year before the present value. Or it depends on how long you're compounding. If it's either monthly, it will give it to you 1 month ago, things like that. So you have to be careful that you are always looking at the correct measurement of time. What I could do after I have that issue is that I could bring up that back with just bringing the money from the past to the present. Annuities are going to be very important because they're going to be used for bonds specifically. Because in bonds, you want the present value of the annuity, which are going to be the coupons, plus the present value of the final payment, which is the face value, if you remember. And all of this is going to be computed at a specific rate, which is called the yield. So all of this are going to give us the payment option. But what if you have a perpetuity? Perpetuities are the ones that go on forever. And this is usually the case that will happen with the stocks. You don't have stocks for a specific set of time. You will have them basically until the company disappears or it goes broke or until you die, whichever happens first. So these are going to simulate a bit more like a perpetuity because they'll keep going forever and ever, the payments. So how can we calculate the present value when it's an infinite horizon? The formula is actually extremely simple. You get the coupon or the amount that you're receiving each period, and you're going to divide it with the interest rate. That's it. If I'm receiving $8 monthly, I'm just going to take 8 divided by the monthly interest rate, and that's it. I already have my present value. The only thing you might start thinking when it gets complicated is what if the payments start growing, which is usually the case with companies in the stock market. Maybe they're giving dividends, but their dividend is growing over time. So how can we calculate the present value of a perpetuity that's growing and growing and growing each period? Well, if you have a specific percent for that growth, it's actually still again pretty simple. You're just going to take the coupon or the payment, inflow and outflow of cash flow, and then you're going to divide it by R, which is the interest rate minus the growth rate. So let's suppose the interest rate I'm using is 8% and the growth rate is 5%. I'm just going to put it divided 8% minus 5% only divided by 3%. And this is going to give us the present value of a perpetuity that is growing forever. Also, you have to have in mind that you can get these formulas with Excel, but Excel will again give it to you one period before the payment starts. So this is not an issue, but it's something that you should consider when calculating annuities or perpetuities. When looking into corporations, you might also find something interesting about perpetuities, and it's that companies are trying to analyze and get analysts to get their perpetual growth rate, which is going to be that growth that I was discussing. How much is it going to grow perpetually? And this value, it's going to be called the WACC, or WACC. This is basically the IRR for a company. And if you Google it, you might find the WACC for Apple, Amazon, or any other stock that you're interested in knowing. But these are only going to be analysts' estimates. You can't really get a definite amount because all of this are going to be done through analysts. And so now that you know how to calculate perpetuities and annuities, and you can see that it's pretty simple with Excel, I want to finish up this episode by showing you how to calculate the present value and future value of any asset that you want in Excel, because Excel is going to be probably the best thing that you can use for calculating present value and future value. So now that I'm sharing my screen, I'm going to show you exercises about present value, future value, NPV and IRR, which are what I talked about in my last episode. And here I'll also start talking about annuities and perpetuities and how we can see those in loans, stocks, and bonds. So I brought one exercise for each type, and I'm going to start with a present value exercise. So let's suppose in 5 years from now, you want to buy a car that will cost $40,000. You have a savings account that will pay 4% interest compounded monthly. So how much do you need to deposit today in order to get that money in the future? Well, for solving this, my advice is to write in one column the 5 variables that you need, which are always going to be future value, present value, interest rate, years, and payment. And also, then you're going to write the formula in Excel for solving this. This will be extremely easy, but what you have to have in mind, it's always the compound frequency, which here I added in a different color so you can notice it. It says the money will be compounded monthly. So this means there are 12 compounding frequencies in 1 year. This will take us to modify our periods to not be 5, but they're going to be 5 times 12, which will give us 60 total periods. And then our modified rate won't be 4%. It's going to be 4 divided 12, which will give us 0.33%. Basically, we're going to pass all of our information to months, and this is going to affect all of our measurements. But the value that I have here in yellow is basically just applying the Excel formula. As my computer's in Spanish, you see that my formula, it's VA, but in English, you would see it as a present value formula. And here, you just have to insert all the parts from the equation. So you get the rate, you get the number of periods, you get the payments, which in this case would be 0, and then you get the future value. You press enter, and then you get the result. You would need $32,000 with 760 with your amount today in order to get $40,000 in 5 years from now. This is how we calculate present value, because we're turning those 40,000 to bringing them up to present value. But not now, let's do the opposite. I have over here an example that's showing you how to calculate the future value. And for this one, we'll switch up the situation. Let's say you want to deposit $1,000 today and $500 monthly for the next 5 years in a savings account that will pay 4% interest compounded monthly. How much will you have in the future? This exercise is going to be a little bit similar to the one we previously saw, but here you're going to deposit an initial amount and then you'll have recurring payments. So this will add another layer to our formula. Let's see how I solved it here in Excel. First thing I did was write, again, the 5 variables that we will always use: future value, present value, interest rate, years, and payment. And here, as I modified the frequency of compounding, I modified my periods and I modified my rate. But I'm going to introduce all of this in my future value formula, which is going to give me the rate, new rate here, then the modified periods, the payment that I'm doing, which is $500 monthly, and then the initial payment I had. So if I start depositing $500 monthly, I will have, at the end of 5 years, $34,000. This seems pretty simple, and that's the truth. If you have Excel and you have your organized facts, it's going to be extremely easy to solve any financial problem. Now let's go to seeing how the NPV and IRR look in one of these cases. I have over here a set of cash flows for hypothetic project. So let's assume you have to invest $18,000 today, and in first year you'll get $5,000, in the second year you'll get $7,000, and in the third year you'll get $10,000 back. Is this project profitable? We'll have to see. First thing we have to find is the net present value of this project with the expected cash flows, and we can suppose it will have an interest rate of 8%. So if we follow this formula, we can create a table where we have 3 specific columns. And in my university where I'm learning, this is called Mike's method, but he likes to call it ABC method because you just have to do something in column A, something in column B, and something in column C, which is going to be the amount of years, the cash flow, and the present value of that cash flow. Now what I'm going to do after I have all the years and all the cash flow sets is I'm going to introduce the present value formula for each one of these ones. Present value, present value, present value. And what I could do is just add all of this up, and this would give me $569, as you can see on this corner. But Excel is also very cool, and they've developed a VPN formula. And this one, it's called, in Spanish, VAN formula. And what we're going to do is set up the exact same thing. So I'm going to put the rate, and then I'm going to introduce the values. And for this, I'm going to end up adding the present value. Here, we can see that I get the exact same amount as I got by doing this manually. So you can decide if you do it with the Excel formula or if you do it manually, or you can do it with both, which is what usually all of the financial people do as they want to double check the process. Then, what if we want to find the IRR, which I told you is the internal rate of return of a project? This one is the easiest of them all, because Excel has a specific formula called IRR, which in Spanish is TIR, and here you just have to select all of the cash flows, press enter, and it will give us that it's 9.56%. So the IRR of this project is higher than the discount rate, and the NPV is positive. So if we were to take this project, we should definitely do it, because it's going to create a lot of value. Now, let's move on to my 4th example, and this one's going to be regarding loans. Let's say you plan to take a 25-year mortgage on a house that costs $1 million today. The interest rate per month is 0.25%, and your first payment is going to be due in 1 month. So how much do you have to pay? This, you can find it with the payments option that I was telling you about when I was talking about annuities. So what you need for finding this formula, it's the present value, which we already have, it's $1 million. The years that you'll be taking this mortgage with, which is 25. And then we have to pass it all to months, as we have an interest rate per month. So here I'm multiplying my years times 12 to get 300 months. After that, I can just introduce everything into my formula, which in English would be PMT, and I just have to put rate, number of periods, and then the present value, and that would give me that I would need a monthly payment of $4,742 for paying my $1 million house. The last two examples that I want to do are the stocks and bonds examples. For stocks, we're going to see an example of a perpetuity. And for this, let's suppose a company will pay a dividend of $4 at the end of next year, and thereafter its annual dividends will grow at a rate of 2.5% a year. What is the first price of this stock today? Well, basically, what we have to do is just take up the discount rate that we have, which is 8%, and take 2.5% away from that. And since we already have the value from the first dividend, I'm going to do 4 divided by 8% minus 2.5%, and this will give me $72.73. So if this were the case, and I'm considering if buying or not this stock in the stock market, I should only buy it if it's this price or lower. If it's higher, it would be overpriced, and this wouldn't be the proper price that I should gain. Finally, let's do an example for bonds. And this one's pretty simple. It's just for bonds, you need to remember all the jargon that I was talking about in my first finance episode, because this is asking, what is the fair price for a bond with coupons of 5 for the next year, face value of 100, and a yield of 8%? So when we see all of this jargon, you might get scared, but you have to remember the yield means discount rate. Coupon means annual payments, and the face value will be the future value. And number of years will be the same in any language, financial language or normal language. So you just have to take all of this up and calculate the present value, which is how is considered the fair price. I hope all of this is making sense now, and you can see how easy it is to calculate present value, future value, NPV, IRR, annuities, and perpetuities, all of it in Excel, because it's just one click away from getting a solution and showing you the optimal financial decision.